Hello everyone, I welcome all of you for this IGBC AP exam preparation course. Myself Saranan J. Bharati from Carbon Figure Academy. In this module, we will be talking about HVAC, that is HVAC systems. A HVAC system stands for heating, ventilation and air conditioning. It's a technology used to provide and regulate indoor environmental comfort by controlling various aspects like air temperature, humidity, and air quality within residential, commercial, or industrial buildings. So, in this visual that is being provided here, we can able to understand the different components of a typical HVAC system. So, it is in between outdoor and indoor scenario. From the left side, you can able to see outdoor is getting entered into the system, and in the right side, right end, we can able to see the conditioned air is getting supplied into the building, right? So if you see the different components, condenser coil, condenser section, compressor, fans, blower, motor obviously, then heating section, then air return duct, where in the other section like cooling coil, air filter, and some duct work, right? So these are the different internal components which exist in a typical HVAC system. So in case of heating, it provides warmth during cold seasons. What are the equipments similarly? Like furnaces, boilers, heat pumps, or electric heaters. So heat is often distributed through radiators, ducts, or underfloor systems. So the scenario is we all, from Indian point of view, we are not aware about, we are not much aware about this heating equipment, because majority of our geography is about semi-arid scenario, where our typical temperature would be around 36 to 40. It is getting varied between, and we have hilly regions as well, but still we are not that much like cold and western part of the world that we may extensively be aware about heating kind of equipment inside the buildings. But there are different kind of air handling units are there under the broadened category of HVAC systems. So the heating is being done by either furnaces, boilers, heat pumps, or electric heaters, right? So it's normally being distributed through radiators, ducts, or underfloor systems, right? So in case of ventilation, that ensures fresh air circulation, right? Removing stale air and pollutants from within the building. So it helps maintaining air quality by filtering dust, smoke, and allergens, right? So what are the systems? So natural ventilation we may have through windows and vents, or mechanical ventilation system, that is nothing but exhaust fans, air handling units, all those things, right? So here in this module we'll be talking about the mechanical ventilation only, right? Then air conditioning comes. It provides cooling during warm seasons. It regulates humidity to avoid excessive moisture within the building. So what are the equipments? It could be air conditioners, chillers, and heat pumps, right? So what is mean by refrigeration? So in this entire model, we will be talking about typical significant concepts rather than much detailed information, right? So we are not into the core of mechanical engineering concepts, but still we will be getting to know about how this cooling and HVAC systems functions overall, and what are the different options available, what would be the typical difference between one system with the other. So that's what we will be covering here, and that is enough from the exam point of view as well, right? Once again, I would like to remind that the IGBC AP exam will never have the questions with numerical calculations. The entire intention of IGBC AP exam is testing you whether you have received the conceptualized ideas about making a building green, right, under various domains and subsets. So it's all about understanding and how you take choice of different things for a given situation. That is what the ultimate aim of IGBC AP exam. It is not like competitive exams where you may need to do some numerical based calculations and all, right? So you don't need to worry about any numbers or formulas you see on the slides, right? So what is mean by refrigeration? The basic principle is that to transfer the heat from a space or substance to make it cooler, right? So which means there is a space. From that space the existing heat is getting removed out of the place. That's all, right? So it works on the second law of thermodynamics. There are three different laws are there. So it is based on second law of thermodynamics, which states that heat flows from higher temperature area to a lower temperature area, right? In refrigeration, this natural flow is reversed using mechanical or chemical processes, making it possible to cool the desired space, right? You just read it once again to understand. In the refrigeration, the natural flow, that is, heat always flows from higher temperature to lower one, right? So for example, higher and lower, what it indicates here in this context, we take a building. uh, Out of the building there's a temperature is prevailing, inside the building there's a temperature is prevailing. Obviously there would be higher temperature exist outside and lower temperature exist inside of the building. So naturally what should happen? From the outdoor the heat has to transfer to the inside. That is what is happening, right? So this refrigeration, in this concept, what we are doing, we are trying to reverse that. So from the inside of the building the heat is getting disposed or displaced to the outer environment, right? So that is what is being mentioned. So because of that only it is called mechanical, right? So we are forcing it to happen. So what is the fundamental key principle behind the refrigeration? The process revolves around refrigerant undergoing a cycle of compression, condensation, expansion, and evaporation. Right? So we don't need to worry about all these things. So there is a substance called refrigerant that is all being the reason for bad names of a typical air conditioner. Right? Nowadays people are coming up with eco refrigerant, which means potentially having lower GWP, that is global warming potential, or ozone depletion potential, ODP. So right, so that is what the substance is all about. So that refrigerant, so normally people say gas, right? So that is what actually the refrigerant. So when you normally shift your air conditioner from one place to other, which means whenever you change your house, from rental to other rental, we have come across at least 6 or 7 rental house changes so far. So every time we used to take out our air conditioner indoor and outdoor unit, the people will say gas got completely leaked. So there is a way to lock the gas and take it out, but still it's all depending on how long it takes during the transit, right? So efficiently talking, during the transit anyhow the gas is going to leak, partially or completely. So whenever we install in the new place, there the gas has to be refilled once again, right? So they may take some bunch of amount for that. So that gas is the local language, and technically that gas is nothing but the refrigerant, right? So that refrigerant undergoing a cycle of compression, cycle in the sense continuously it is happening whenever you use it, right? Compression, condensation, expansion, and evaporation, right? So that is the underlying principle they are telling. Because of this continuous action, the heat inside the building is getting displaced due to the outside of the building. That's it, right? So in this simple infographic, we can able to see hot space T2, right? Then cold space T1, right? So transfer heat from cold space. Cold space T1 is nothing but inside the building, right? That is getting onto the refrigerant, and that refrigerant is being mechanically forced for compression, condensation, expansion, evaporation, and during which the heat is further transferred to the outside of the space T1. So that new space is T2, obviously the outdoor of the building, right? So that is how the heat is getting displaced. So cold space becoming more colder, right? That is what you should understand. So there are technical terms how to measure the performance of refrigeration or ability of doing it, right? So capacity of refrigeration is usually measured in tons of refrigeration, TR. So normally people used to ask how many tons your AC, right? One ton, 1.5 ton, 2 tons, right? So which means whenever the ton is increased, the capacity it can cool the air inside the building, that given space will be more. So normally when we would like to purchase the air conditioner, we would like to measure the space of the room. Okay, this is this much room, we may need 1 ton is enough. No, this is big, no, bit larger, we may need 1.5 or 2, right? So depending on the local climate as well, right? So for example, in Tamil Nadu, we have certain places which is meant for high temperature scenarios, during summer, comparing to other locations like Vellore, Madurai, Tirunelveli, uh, Chennai, obviously, right? So these are all the places where even though there is a small space which can be surviving with 1 ton of AC, no, it's not enough for this temperature, we got to get it more, right? So it's also depending on not only on room size but also depending on the local climate, right? So 1 ton of refrigeration is equal to amount of heat to be removed to freeze 1 ton of liquid water at 0 degrees Celsius for 24 hours, right? Which is equivalent to 3024 kilocalorie per hour, right? So 1 TR is equal to amount of heat to be removed, right, to freeze 1 ton of liquid water at 0 degrees Celsius in 24 hours, right? So coefficient of performance. So how other way we can measure the performance of your refrigeration? So that is COP, amount of heat to be taken out divided by amount of work required. So it is like T1 divided by T2 minus T1. So T1 is evaporator temperature in Kelvin, T2 condenser temperature in Kelvin. So these So these two terminologies, T1 and T2, evaporator temperature and condenser temperature, we can able to see in the key principle, compression, condensation, expansion, and evaporation, right? So based on that only the COP is being measured. So we are having different options with respect to HVAC chillers, especially that air conditioning. So what are the different types? Vapor compression chillers, vapor absorption chillers, and condenser types, right? So we have the visuals like window air conditioner, split air conditioner, packaged air conditioner, and centralized air conditioner. So we will talk about, we know very easily the difference between window air conditioner and split air conditioner. We will get to know about the difference between packaged AC and centralized AC. So regarding the chillers, Under vapor compression chillers, we have a reciprocating system, centrifugal system, screw and scroll system, right? Vapor absorption chillers, we have single effect, double effect and triple effect options. And condenser types, if you take air cooled condenser, water based condenser and evaporative condenser, right? So we don't need to worry much about for each details, but you just get to know how HVAC systems are fundamentally classified: vapor compression and vapor absorption, right? So let's get to know about the difference between packaged AC and centralized AC, right? So if you see the visual, we can able to see that the refrigeration system is being put out of the building, and from that the cold air is being supplied throughout the building with the help of duct. But both are looking same, but there would be some difference, right? So let us just ask ChatGPT difference between packaged AC and what was that? Centralized AC. Design capacity application, right? So in the description we can understand packaged AC is a self-contained unit with all components in a single casing, that is packaged casing, like compressor, condenser, everything. Centralized AC, it's a system where cooling is produced in a centralized location and distributed via ducts or chilled water pipes. Still I can't understand the difference. Okay, all in one box, typically installed outdoors or on the roof, packaged AC. Okay, centralized means composed of chillers, cooling towers. Okay, so the component wise, there is a kind of difference between packaged AC and centralized AC. Capacity and usage, if you see, medium capacity 3 to 25 tons, whereas packaged AC. Oh, centralized AC suitable buildings above 25 tons loads. Oh, centralized AC is the bigger one, right? So packaged AC is a kind of uh, what to say? It is just like bundling both indoor and outdoor unit at the same place in a single casing and supplying the cold air into the building through the ducts. That is what I could able to understand. That is packaged AC. Centralized AC is like completely different set of components like chillers and towers and AHUs, right? Ductwork. So I hope that would be somehow answering, right? So that's the different types of things, and we just get to know about what is mean by AHU and ATU, right? So an air handling unit is an essential component of HVAC systems responsible for regulating and circulating air throughout the building. It ensures that indoor environment maintains the required temperature, humidity and air quality by conditioning the air and distributing it through the duct system, right? Air handling unit. So it's not only about the temperature regulation, it's also taking care of humidity and air quality. That is very important, right? So in the right side picture there is a typical representation of an air handling unit is provided, right? So it is also about cooling. It is also about displacing the bad air within the building with the continuous fresh air from the outdoor, right? So air terminal unit is a device used within an HVAC system to control the flow and distribution of conditioned air into different zones of a building. It serves as the final control element before air is delivered to the space. So it is like it is not a two different set of concepts. It is ATU is the final component of AHU, right? So how we can differentiate them regarding the function? It AHU regulates and conditions air for the entire building or zone, whereas air terminal unit controls air distribution and volume at room or zone level, right? So regarding the location, typically located in mechanical rooms or on rooftops, where what AHUs, right? In case of air terminal unit, placed in ceilings or near the zone it serves, because we all know ATU is the final stage of AHU, final component, releasing component of AHU, right? Right. Uh, Regarding what else? Cooling and heating source. Air handling unit uses chilled or hot water from central plants, whereas air terminal unit adjust flow of centrally conditioned air. It's just channelizing and distributing the cold or hot air, right? So, so in case of application, air handling unit is ideal for large buildings and facilities, whereas air terminal unit ensures individual comfort in separate zones, right? So in a typical IT companies, IT firms, we can able to see the designs of interior in their interiors, that air terminal units would be transparently visible just overhead, right? So earlier days, people would be covering that, with the false ceiling or lower level ceiling, so that you don't see all those mechanical systems and all. But as a evolution of modern trend and interior design, people started removing that false ceiling completely, and make you to exposed to the internal components. But over the time, that internal components start getting painted in different colors. That means that duct, pipes, all those things, and ultimately it looks good, right? So I have witnessed such one of the IT companies while I was appearing for an NPTEL exam. So it was that Infosys, located in Pallavaram, Chennai, right? So near Pallavaram, Chennai, right? So that is what air terminal unit. So right. So energy efficiency, obviously it can serve multiple areas, leading to energy savings. And air terminal unit optimizes comfort by controlling individual spaces. So in the right side picture, we can able to understand that you know air handling unit and air terminal unit. So in the left side, top left, what you see is air handling unit, right? So it's directly going there, and that green color thing is nothing but air terminal unit, right? So within that air terminal unit, what we can have is that VAV boxes, varied air volume device, we can say, right? So in the one side, there is no VAV boxes. In the right side, we have VAV boxes. So because of the presence of VAV boxes, what is happening? The air is being supplied based on the requirement of the particular zone, right? So in the left side, you can see three different spaces. Two spaces are completely empty without people. Central alone, there is a person, right? But in constant air volume concept, what will happen? The AHU will keep on pumping the air into equally into three spaces continuously, right? It won't mind about whether there is a people is inside or not, right? But in system, AHU system, which is attached with variable air volume controlled devices, VAV boxes, it can understand, okay, one space is completely empty, so there you send the minimal amount of air. So in the second box, three different, which means it's completely occupied, spend more amount of air supply there. The third box, only one person is there, which means it is partially complete, which means partially occupied. So send accordingly, the amount of air. So that is what the concept of constant air volume and varied air volume with the help of AHU and ATU, right? So in terms of air conditioner and air handling unit, we can understand the difference between, like, air conditioner just cools and dehumidifies individual rooms or small spaces, whereas air handling unit circulates, conditions, and distributes air across multiple zones or entire buildings. So which means AC is small, AHU is somehow large concept, right? So capacity wise, if you see, typically air conditioner 0.5 ton to 10 tons, whereas air handling units may have capacities from 50 to 1000 plus tons. So now you can understand how that big malls that we visit, completely cold inside, right? So those kind of malls are installed with such number of air handling units, because mall is completely vast and open, right? But still it is cold inside. So how much amount of AC they are spending, we used to think normally, right? So it's not about from the air conditioner. Typically we know it is all about from air handling units, right? So cooling mechanism, if you take, ACs are talking using ACs are using refrigerants, whereas air handling unit uses chilled water or hot water from a central uh, plant. There is no compressor because it's completely with water, whereas in air conditioner it is all about refrigerant, right? So location, obviously inside or near rooms, whereas AHUs are installed, rooftops are separately designated places, because it is going to get supplied through ducts only, right? So demand control ventilation, this is the concept that I have already mentioned, varied VAV boxes. So it is an intelligent HVAC strategy that regulates the amount of fresh air supplied to a space based on real-time occupancy and air quality levels. Right. So the goal is to optimize energy efficiency while maintaining indoor air quality by supplying air only when and where it is needed, right? So how it works, so it is like, in the cycle we can start with the blue color. Sensors monitors air quality or occupancy, right? So we may have installed CO2 sensor, occupancy sensor, and VOC sensor. Because of that we get the reading, and that reading is sent to the HVAC systems, that is nothing but air handling units. So what it will do, it will supply fresh air adjusted based on real time data feed. So it is continuously helps maintaining indoor comfort and energy efficiency, right? For example, when there is no people, that certain segment of the air handling unit would be completely turned off. Just like when we watch YouTube in televisions, connected in televisions or in smart TV, if you don't use your remote for longer time, after certain timer it will show up like, you don't use the TV, shall I continue playing the video, like that the notification will pop up, right? So that is functioning based on a timer based setting, right? Same way AHU works. So in the typical visualization, it is again showing the same kind of example. This is a inside of a typical zone or a room, right? So at the bottom, people are standing. So you just try to understand their height level and height of the roof, and inside the roof there is a blue color hanging. That is nothing but the ducts, air terminal units, right? So for that air terminal units, where the air supply, that AHU which are installed at the rooftop, right? So from there, the air is getting supplied inside the building. Now your CO2 sensor is actually installed at the height level, like height level of people, typically like 5 feet to 7 feet. That range, the CO2 sensor should be installed. So that CO2 sensor senses the amount of oxygen available, like senses the amount of CO2 inside the building. When there is more people, they started breathing, every other oxygen available inside the building, and they release more amount of CO2. So because of that reading, that air handling unit will continuously supply more fresh air into the building, so that the CO2 level keeps on maintained during a particular, range, right? So when there is less number of people, again the CO2 sensor, okay, it is only low level. So accordingly, you can lower your speed of supply, right, or rate of supply, we can say, right? That is what that demand based controlled ventilation, right? So recommended height for CO2 sensor is 3 to 6 feet. I told 4 to 7, sorry, 5 to 7, but still it is accompanying the average height of the people in most cases, right? So that is nothing but 1 to 1.8 meters above the floor level, right? So why? That is the breathing zone, right? So what are the different, low energy comfort cooling technologies, right? Because we are all talking about how to make it green, right? So we understand these are the different HVAC systems are available. So how to make them, green? What are the different options? So they are called collectively as low energy comfort cooling technologies. So we have different options, like 5 different options is being mentioned here. First one is radiant cooling. Second one is evaporative cooling. Third one is geothermal cooling. Fourth one is night purge ventilation. Last one is solar assisted cooling. Right. So what is radiant cooling? It is chilled water pipes embedded in floors, ceilings, or walls absorb heat from space. Right. So in the left side there is a simple diagram. So roof, walls, and floor of the building is being, buried with some tube kind of things. So they are nothing but chilled water pipes, inside which the water will be in a continuous flow or kind of a stagnant, right, depending on the condition. So what it would do, because of that chilled water inside the pipe, that surface, roof, and wall will get cold with the help of that radiation, right? So because of that, the inside temperature would be normally controlled, so that we don't much, require the use of HVAC systems, right? The mechanical systems. So how it is happening? Like it is uses water uh, uh, heat capacity than reducing energy consumption by up to 30 to 40 percentage. Sorry, uses water reducing energy consumption. So water in the sense higher heat capacity than air. So that is why the water is being used. That is the logic, right? So in case of evaporative cooling, air passes over water saturated pads and evaporation cools the air, right? So it is like when there is temperature, when you give work to the temperature is vanished. Can you understand? So if you feel heat, to avoid the heat impact yourself, you give the heat some other work to do. So that work is nothing but evaporation. Okay, I pour water, I spray water. So what happens? So when you spray water in a heat environment, that heat will be converted to evaporation, converted in evaporating that sprayed water, so it won't affect you, right? So that is what evaporative cooling normally is done. So it uses 80 to 90 percentage lesser energy compared to air conditioners, right? So people are nowadays changing, shifting to evaporation based cooling only. That is also in line with natural and passive cooling strategies, right? So geothermal cooling, underground pipes use stable ground temperature to pre-cool or preheat the air. So it can't be installed everywhere, because a typical temperature required and installation cost, the maintenance cost, available of resources, skilled resources. So based off all these things, this is kind of okay, it's an option, but still we can't use it everywhere. Then night purge ventilation uses cooler night air to flush heat out of the building, reducing the next day's cooling load. So what they are indicating, it is cooler night air. So uh, it is all about capturing the nighttime air, using it, storing it, and releasing it during the daytime into the buildings, right? So it's a kind of energy efficient scenario, but I really don't know what are the typical kind of equipment, installations requirement, performance about this kind of system. Then solar assisted cooling, we have solar energy, enormously, obviously. So that can be utilized in powering absorption chillers or fans, reducing grid electricity use. Right? It's just a normal air conditioner aided with solar, supplied electricity. Right? So certain air conditioners are coming in the market, like solar AC, so which can run both with the help of our usual electricity and also from solar based electricity. It's just a switch. If you just turn on, it will cut off your building's energy supply and get only from solar panels, right? So depending on your local climate, you can use the solar. It obviously cut off some amount of energy consumption, right? So finally we have building management system, nothing but BMS. It's also known as building automation system, BAS. So it is a computer based control system installed in buildings to manage and monitor various mechanical, electrical and plumbing systems. So just a second. So sorry for the interrupt. So the BMS or BAS is all about, we are installing different electrical and plumbing and mechanical systems so as to regulate the air inside the building for heating or cooling. So all these things, in case of a large building, you just think about an entire apartment or commercial complex where n number of such installations are there. So how to efficiently manage them so as to save a lot of electricity and the finance. So we have to coordinate all of them, right, at a centralized location. So that concept is nothing but building management system or building automation system, right? So depending on how higher order of instruments that you are installing, this kind of centralized facility will be required. So you can able to see what are the different operations: AHU, chillers, boilers, pumps, and variable frequency drivers. In this side management operations, you will have FAS, EMS, elevators, energy meters, water meters, CCTV. So all together you can integrate and you can monitor from a single spot, right? So this kind of unified and centralized management system, building management system, will help in enhancing operational efficiency, reduces energy consumption, and ensures occupant comfort by automating the entire building operations, right? So that's it. So that's it about HVAC system. In the next module, we will be talking about sustainable building materials and resources, right? So once again, I remind the entire module wise videos will have the respective module wise quiz, uh, and the link for the quiz is being provided in the description box of each video. So I hope that will be very much helpful for your self assessment once you complete each module, right? So at the last, after completing all the modules, I will post a separate video about mock exam and relevant guidelines, where you can able to see the links for mock exams in the same description box. Thank you. We will meet again in the next module.